This winter we were particularly interested in what happened under the ice, especially in wintertime. We have different reasons to be interested in that. One part is that we're collaborating very tightly with the biologists in figuring out what happened under the ice. Another part is the engineering research. We do collaborate with the JPL lab in NASA in LA, and they have a very strong interest in what happens on the icy moons of Jupiter and the icy moons of Saturn. And to have the technology, have the understanding how can we navigate under there. The best analogy is the ice-covered areas that we have here on Earth. So one thing that we were really curious in, can we use the hyperspectral camera that we carried with the Blueye to navigate, to find features and landmarks that we can use in our navigation algorithms. Our eyes and a conventional camera will collect light in red, green and blue color band and mix them together to make us sort of see the colors that we see. This hyperspectral camera will record the full visible light spectrum from sort of the infrared to the ultraviolet. And that sort of, you can think of this as high resolution color image. And we can use this to identify marine pigments such as chlorophyll or beta carotene. Knowing what pigments we have, we can also say something about what are the species there. We also looked into, can we use this sort of extended color information to find more features in the ice for navigation, just for the space application that I mentioned. It's difficult to estimate how thick is the ice, how much ice algae is there. Ice algae is the algae that grows on the underside of the ice. If we can have more measurements with the hyperspectral imager and relate this to remote sensing or satellite imagery, we can have much more information from the remote sensing data. So this is an important sort of connection going forward. You see, how can we make one sensor better by using the hyperspectral imaging. So ice thickness is important because it's covering up a lot of fresh water in the Arctic, and it also sort of defines the natural habitat for all of the nature up there. I started to go to Svalbard 20 years ago, and some areas I cannot recognize because they change so much. And that also goes for the ice. It's much less ice. And to understand this rapid dynamics of the habitat for the Arctic environment is important to understand how the Earth will change with the rising temperatures. We were particularly interested in temperature and salinity because much of the work was related to ice and ice mechanics. And how well was the water mixed below? Was it like a uniform temperature, or was it a strong vertical temperature gradient? And we saw that the ice was quite cold, between -1 and -2. So when we work in the Arctic, logistics is always very heavy. It takes a lot to bring all the equipment there, and having equipment that you can depend on, that you can rely on, is very important, because if you break down, you don't only lose the equipment that breaks, but you lose all the value of getting there, setting up your equipment. So you really want something that works. And we had an also established instrument from Ecotone that we carried along, the hyperspectral imager, and we used sort of our own engineering to put them together. So we used 2 Blueye vehicles to carry one hyperspectral imager. For us, this reliability and the robustness of the Blueye was very, very important for the expedition and the work we did up there. We would like to have a third person view from the double vehicle, so we can see what it was doing, how we were navigating, and we basically got a much better situation awareness when we had 2 vehicles collaborating.